Okay, so let's start the workshop. So, uh, good morning. Good morning to one and all. Well, welcome to Dhruva and welcome to today's workshop, which is an introduction to game development and design. Introducing myself, my name is Tejashwin. I'm a third year student at IIIT Kottayam, pursuing my BTech in computer science and engineering. So, today's session. Today's session, we are going to talk about what you can do with game development, how to get started with game development, and maybe a little walkthrough in the Unity engine, and then let's brainstorm. And then we are going to brainstorm some game design. Why not? So, what is game development about? Simply put, game development is making games that are playable and fun. There are a lot of tools available for game dev. Some of the tools being Unity and Unreal. Oh, yeah, I am that good. Okay, so yeah, there are a lot of tools for game development like the Unity engine and Unreal engine. There are frameworks like SDL, SFML that use C++, and Pygame for Python. Game development is a lot similar to software development. Most of the development cycles that you see in game development are very similar to the software development life cycle, and there are and the workflows that you try to use in a game company are very similar to that of software engineering. And game development is a lot dependent on computer science fields, and it's a little bit of everything. For example, the AI that you use in games, uh, for example, for AI and for other matchmaking models that use machine learning, cloud computing, of course, for multiplayer games, and data science, of course, to store data of each and every player playing in the multiplayer game. So what are the takeaways that you can get from the game dev? By this, I mean, what are the benefits that you get? What are the benefits that you get, or what do you get from exploring this field? So as a career, games are of course gaining popularity day by day. It's a very popular. It's of course an increase. It's a progressing entertainment field, and most of the people who play this are teenagers. So of course, justifying it as a good entertainment field, and it's also progressing as a career well in India. And but more than a career, it is more beneficial as a hobby, where you can develop game projects in your favorite programming language, and build your portfolio resume. For example, for web development, I've seen many people use a 3.js, which uses shaders, which is good for game development as well. And of course, this also helps developing your dev and the programming language. Yeah, just a minute. Okay, yeah, hello. Sorry about that. It was a little emergency. So yeah, continuing with this, of course, game dev is also a good medium to understand computer graphics, which is a major computer science field, which also progresses outside game dev. So how to get started with game development? Well, there are many fields that you can cover in game development, which are very vast and diverse as well. For example, starting out with the programming languages, the popular programming languages that you can use in game development are, of course, the best one being C++. Many of the games that are developed today are made in C++ because it is very powerful, and Most of the graphics APIs also use C++ libraries. And of course, other languages being Java, which is Java being a good game development program is because one game development is very much dependent on object-oriented programming, and Java is of course an ideal programming language for ops. Then also we use scripting languages like of course Python, and there is also this scripting language known as Lua, which is very much in the game development field and used in a lot of engines to script game logic. Moving on to computer graphics, of course, as I've told, C++, there are a lot of graphics API libraries that use C++, some of them being OpenGL and Directx. Directx is developed especially by Microsoft, and most of the games today that you see in Microsoft, that you run on your Microsoft platform or your Windows platform are DirectX graphic games. And also from computer graphics, you can also diverse into shading languages, which are of course used to write shaders. I'm sure you have heard of shaders somewhere when you're playing games, for example, in Minecraft or else in any other game. And then of course, then we go for 2D and 3D design tools, where you basically create the art for the game, or even the 3D models or the graphics for the games. Some of these being some of the examples being one is the Blender and Maya for 3D modeling, and of course Photoshop, all the Adobe photo editing and art tools, which are Photoshop, After Effects, and Illustrator, and all these tools. Coming to game engines, of course, as I mentioned before, there are a lot of game engines on the internet. Some of them, the most famous ones being Unity and Unreal. And in the recent years, also there has been a really good game engine in the name of Godot. It is spelled as Godot, Godot, which is an open source game engine, and which is also open source game engine, which has a very vibrant community, always helping out each other. So I definitely recommend you to try out Godot if anybody has the chance to. And then of course, audio tools for your audio implementations. A good game isn't complete without good audio, or even good sound effects. I'm not talking about the background music also. I'm talking about the sound effects, all the effects that all the audio implementations that you see in a game, which create the immersion for a game. Those are also very important as well. And of course, then in the end we have game frameworks like Pygame. And so usually people ask, what can I choose between a game engine and a game framework? And of course, there are a lot of preferences based upon which engine or which framework to use. And of course, I'm going to talk about that later. And yeah, for the popular game engines and frameworks, there are a lot of the famous ones, of course, are Unity and Unreal, which are Unity is scripted in C#, and Unreal is scripted. Unreal is a more low-code type of approach where you use visual scripting, but also use C++. libgdx is a framework that you use use for Java. And of course, Godot, as I've told, Godot is a very good game engine that has been becoming popular in the recent years, which uses its own scripting language known as a GD script, but it also uses plugins for C#, C++, and Lua. The Corona Labs thing was actually, yeah, as I've told you, Lua is also one of the important scripting languages in game development. And look, Corona Labs is basically one of the SDKs used to make mobile games. It was very popular like in the mid 2000s, but now I think there haven't been much like updates or like patches for the game engine. And of course, Mono Game, Top 3 are all Lua. and Love 2D is basically a 2D engine. 2D framework for Lua. JMonkey engine is for I think is for Java, and also yeah, and I forgot to mention Lumberyard is currently, I think in this year, is currently one of the most in-demand game engines for commercial companies. This is a game engine that was developed by Amazon, and it has a and has a and automatically has integrated AWS with integrated with AWS cloud services and uh, Twitch, which is a game streaming platform. I'm sure many of you will know. And many companies, maybe one of the games you have one of the games in the current time in this current month you would have probably heard of is I think a New World. If you haven't heard of it, you can check it out if you want. And then of course, yeah, and I said I was going to mention about game engines versus game frameworks. So yeah, when you're deciding or when you're hesitating to try out a game engine or a game framework, there are usually two paradigms from this. So one is I want to make a game, or else I want to learn to program how to make a game. If you're trying to make a game, of course, you can make with a game engine, you can make a game with the minimal experience in programming languages, and because there are a lot of we have a lot of tools ready-made beforehand. You can use visual scripting, and you can use a lot of assets that are available on their own engine marketplaces. And as it says, it uses scripts to code game logic, which is much easier than programming from scratch. And because of this, when you're working in a company which works on a deadline, this is beneficial because in a game company, it's not the game programmer alone. You have a technical artist, you have a you have a game designer, you have a game, all the people who work with the art, with the audio, with the graphics and stuff. So when you're working in such a complicated workspace, it gets very hectic. So and that is why game usually when you're like working in a game, when you want to work in a game company, you are gonna need a like experience in game engines. But if you're trying to become a game programmer, programming frameworks is very important, because frameworks are only like additional game libraries with like support for multimedia stuff, which is like audio user inputs in a programming language. It is much lightweight. Than an engine, of course. And if you want to have experience, and if you want to like develop good object oriented programming skills in that particular language, a framework is very important. One of my seniors, who was also a part of the game development club, developed like a game in libgdx Java. And yeah, when I saw the code for that, it was yeah it used a lot of different APIs, but the core object oriented programming part of the game was still there. And it kind of reviewing code is also like a learning experience for me. So that was that was a very good experience. So I would recommend you, if you like want to program a game, look for frameworks. But if you want to make a game as well as program a game, and look for other more advanced implementations for graphics and stuff, I recommend you a game engine. And of course, the game development, like when you now that you've decided that you want to use a game engine or a game framework, now what comes next is the stages of making the game. Now that you're thinking of making a game, how do you get started on making a game? Of course, the first one comes with a game idea. This game idea could be anything. You want to either make a simple game, like a simple platformer game, or else you played a game that inspired you, and now you're thinking, I want to make a game similar to this, maybe change a little bit more. And yeah, for this and you can be a little more ambitious and like make a game. Like you could think, this game is good, but I can make it even more better, and you can start making a game as well. And of course, after that, in a game company, if you're working with an idea and concept, then comes the part where you get where you have have to work with the art and the design, and you have to integrate it with your project with 3D models, animations, and stuff. Then comes the development part. Of course, you have to creating workflows and iterating these workflows over and over, and until you get a proper finishing product. And in game development, prototyping is a very common practice. Basically, you create a game, you create like the skeleton of the game, and you keep on working over the mechanics, until you're satisfied with what you're making. And then after that, we come to the deployment of the game and publishing of the game. So this I'll explain in the next slide, which is until before like explaining deployment and publishing, I want to explain these areas once again. Like, of course, the game design is the ideation and the design document that you create. Apart from this, game design also has certain elements that you have to take care of, uh, which we'll talk about later in this session. Then comes game programming, which is a programming an engine or a framework. Game art and animation, we've already seen this. And the graphics and VFX is basically, now suppose if I'm playing a game, and now you have all these graphics and stuff, but you have there are certain other graphical parts known as effects, particle effects, which you can probably see in a game. Like now, if I'm playing a winter themed game with snowfall, all the surroundings might be the graphics, but the like the winter, the snowfall, like the snowfall implementation in that game would be called as a particle system, like the particle effects, because these particle effects are consist of very minute graphics very minute implementations that can be hard implementing with graphics alone. And then comes the lighting and post processing. Of course, in a game, okay, we're going to talk about the lighting and when we are doing the game engine, and of course the audio design and SFX we have talked about. And then for a game UI, the game UI is of course the user interface that you interact while playing the game. This consists of two parts, HUD and GUI. Of course, I think you would know about HUD more than GUI, because HUD, which is a full form for, which is the short form for heads up display. Heads up display is the is the like is the UI elements that you see on your that you can't interact, but you can see on your screen. For example, if you're playing a shooter game or so, the amount of ammo in a game, the amount of health or the amount of armor that you have in a game, the shields you have in a game, or the number of teammates that you have in the game, it provides you information that you would need, so that you don't have to go again so that you don't have to again go through like the graphical user interface, which is the settings menu and all the stuff. GUI also consists of interacting with the stuff. So yeah, graphical user interface is the part where you interact with the where it interacts with the player. This is much more noticeable in mobile games, where you have those joystick APIs and stuff, which you tinker around with while taking movement and stuff. Then comes, of course, the level design, and the level design, which is making maps and adding progression to the game. So level design is actually also a part, one of the elements of game design, which comes in the later stages of after creating your prototype. After creating a prototype, now you have certain problems, like, okay, we have a game, we have a certain core mechanic that we have. Now how can I now, but is that the complete game? No, it is not the complete game, right? You still have to add elements that makes the player more engaging. Like, if I just create a game with a prototype and a mechanic, it's not enough, right? So when you're creating a complete game, level design of course comes in handy, because then you have to create maps, levels, like a start end and a end goal, with some obstacles or like with some enemies and stuff. These all come under level design. Game testing is of course the player testing that you might have noticed in many companies under the name closed beta, alpha, and stuff. So this is basically where when you create the prototype, you give it to a certain set of people and start, or else you play test it yourself and see if the game is consistent enough with your design, or else you have a consistent, like you have a good mechanic going around without any bugs. And then comes game deployment and game publishing. Game deployment is basically, now there are many companies which help you in like deploying your game, like building and deploying your game. For Unity and Unreal, it of course automatically helps you build and deploy games for natively for Windows, Linux, or Windows, Linux, or even the web. But sometimes when you're playing a multiplayer game, you need servers, and of course for that, uh, Amazon, and there is AWS, there is Azure, Microsoft has Azure, and of course there is also cloud, which is basically the Google's. You might have heard of Google Stadia, and one of the sponsors of the game development event. Echo 3D is also like a game deployment, a game deployment company which helps you build and deploy 3D AR/VR games. So some of those examples. Then comes game publishing. Of course, game publishing is more of a marketing part of your game, which is basically publishing your game on a website or an interface. Like some good examples you might have heard of course, the Google Play Store, and then the Steam for PC games. And of course, more integrating more on these game project teams. You have a project, you have a technical design, you have a game art design, you have more of, you have in programming, of course there are a lot of stuff. You program the UI, you program, there are people who program the UI, there are people who program the AI of the game, there are people who program the gameplay of the game, which is the mechanics which I've been talking about as a prototype, and people who code all the shaders and stuff. And then of course audio implementations in the game, and of course, and in the end comes the testing and the deployment. So right now I'm gonna like walk through the engine of the game. I'm gonna try implementing some basic game scripting in Unity, trying to go through how many of you, sorry, I'm gonna just ask you guys, how many of you are like have tried out Unity and stuff? So anyone else? Okay, cool. Yeah, that's good. Okay. So okay, for those who don't know, of course, Unity, I've mentioned before, it's a game engine. So wait, I'll just share my screen over here. Wait. Oh yeah, okay, yeah, it's fine, it's fine, it's fine. So in this part, in this workshop, in this so quote unquote walkthrough, I'm going to generalize it as much as possible, so that if you're using Unreal Engine, or if you're using Unity, sorry, if you're using Unreal Engine or Unity or any other framework, the game logic is always the same in all of these engines or framework. So I'll just try to generalize it as much as possible. Maybe I'll use a little bit of Unity API, so that I can just show a working example in this. That's fine, right? I think Ronak Kumar Singh. Using Unreal is fine. So I'll just you guys can see my screen, right? Yeah, okay. So yeah, before like once you, I'm sure the download part of the Unity would be visible. you can just type on Google Unity download, and it directs you to the website where you can download your part. But for prerequisites, what you would want to do is, of course, if you have Visual Studio for you, in your systems, make sure make sure that you have the Unity features available as well. It is available in workloads as a game development with Unity. This will help. This will kind of help with your workflow because it has intelligence and other syntax highlightings and stuff for scripting in Unity. So I would probably recommend you to just try it out. And then okay, now it's visible, right? Now the whole engine. Is it visible? Okay, cool. That's fine. Okay, so now that we're in the engine, I'm just gonna go through a simple walkthrough of what is going around in this interface. So currently you're in the Unity game engine store, and so Unity consists of various layouts. So first of all, in the taskbar, you have the common file, edit, assets, and stuff. As you can see in the window, there are a bunch of stuff that you can use while using this game engine. Some of them being general and the scenes inspector and stuff. And these are all the default ones that are available in your game engine. You can change these. You can change your layouts by either using a custom one, or else you can just drag and drop. Can drag and drop your inspectors as a. So you can drag and drop your inspector as a usual, and that's also fine. Or else you can even go for the default. Oh, sorry. Yeah, going to you can just reset your default part by just going back to the Windows layout session. So and kind of going through each and everything. Hierarchy is basically the part where you consist of all the game objects that you can game objects that you're using in your current part where you can view your stuff. This is called as the viewport. If you have used Unreal Engine, I think this is basically the same. In Unity, you call this as the scene. In Unreal, you call this as the viewport. The scene is the part where you can handle game assets and stuff. But when you're running the game, so when you're running the game, it runs in a game in this window named as the game, where you basically have uh, play test the whole game. So after this, I'll just put this down, and I'll create a new scene just so that. So for this, you will create. And, so I'll just name this sample. And now, okay, this is the example of an empty. Like this is whenever you start your game or create a new game, this is the part where you actually this is the part where you actually get started out. Complete this basically nothing. Only you have is a camera which you use to display all the objects in your game screen, and a directional light. And directional light is basically the light which light the common light that passes down through your game object. If you delete this, basically what's left in your game is a pitch black scene. Fun fact, if you on the top left, usually there are a bunch of stuff which is these are called as the transforms of Unity game engine. Basically these tools are used to move the stuff, rotate the stuff, scale the stuff, and this is a more of a and customly do all of these at once. Usually, if you for a more workflow intensive perspective, you usually have hotkeys like shortcuts, key shortcuts, which are one of your QWERTYs in your keyboards, like QWERTY. So fun fact is, if this directional light, if you if you keep rotating it, on, wait, is it on? Okay, never mind. Once I get the, where is this? I'll just show. Yeah, okay, this works good. If you keep rotating them on your screen, you can see the lighting keeps changing on your scene, right? This is basically the lighting that falls on your screen changes the light data on your whole game engine. So this type, especially this is also very useful in like creating a basic day night type of day night type of mechanism in your game, which kind of works by just rotating your camera with scale of whatever time scale that you're using in your game. It's not always 24 hours, right? So just getting with the SAM. So I want to get started with this game. So I'm just going to create a few objects. So wait, for creating an object, of course, for now, I don't know, I'm not sure. I'm completely, if I'm completely new to Unity, just I want to create a new object. So first of all, I want to like check out my assets folder regarding what all do I have. Okay, this is the ones that I created. Starting off with the scenes. Scenes are of course if you've been noticing, I've been moving around a couple of like implementations in my game. This is all because of the scene part where where I can change from one workflow that I'm working to another workflow. Scenes are basically like levels in your game. If you're for any Unreal users, it is basically called as levels in that game engine. So if you're using like scenes when you're like building your project, once you like build your settings, in your build settings, you basically it gives you like a list where you can like number these scenes one by one. So if one scene is completed, it moves on to the next scene, and then if this scene is completed, it moves on to the other scene. I'll talk about scene management scripting like a little bit about it right now. So before that, I'm just going to create a few game objects on my screen. So with that, first of all, I'm going to create a plane, a basic plane with a now now I'm going to talk about the inspector window. Like you now currently right now you guys can see a bunch of like a bunch of parameters that are maybe way too overwhelming, or so for some it might be like familiar with, or some might get a gist of it, basically like what is happening over here. As I've told before, the tools on the top left are called as transforms. This transforms take care of like the position, the rotation, and the scale, the position, rotation, scale of your game engine, so of your object. So and then comes all the rendering stuff, where you basically render this render this plane on on the viewport. So currently, right now, I'm using a plane mesh. If I want, I can change these meshes to a capsule. Do remember, like the mesh that you're seeing, like the green color mesh that you're seeing around your scene is around the scene is basically like a mesh collider. I'm going to talk about it later. Like currently, I can change the mesh to whatever I want. This and probably like changing meshes also gives like to gives rise to like cool implementations in the scene. If you want, you can like explore it in the internet about like how meshes work and stuff. And yeah, I'm just gonna reset it to a plane. Then of course the lighting and the probes and all the stuff. Probes are a bit of an advanced topic. which basically like you're trying to fine tune your lighting at each and every point of your game engine. And then yeah, this is lighting is of course uh, as I told, I'll explain. I mentioned before that I'm going to explain about this in the like in this part of the section. So of course the lighting of for anyone who want to like explore lighting, I do recommend like the Unity documentation is very good at like explaining basic lighting. uh, but for now I'm just going to explain like lighting is lighting are of like a few types. The lighting that you see here is a directional lighting. Sometimes light, as you can see, there is directional light, point light, spotlight, and these types are as the names say, it can light that points in a certain direction, or else light that radiates from one point. Spotlight is of course like the spotlight is of course the one, as the name says, it completely concentrates all of its light at a certain spot. And area light and all the probes are used to like showcase lighting in a more broader perspective. So yeah, on my plane, then what to do? Yeah, then comes the mesh colliders. Yeah, the mesh collider, a collider for an object is very important because once if you like implement like physics in your game, and you want to know what collisions happen between each and every object, because if there is no collider between between objects, they're just going to pass right through them. And without a collider or a box collider or mesh collider, it's kind of meaningless to create physics in a game. And of course, as I mentioned before, if I create okay, if I just change my mesh to a capsule, and if I change my mesh plane to a capsule, you can see I completely changed my game object to something else. So this is this rendering is very much dependent on meshes. And so yeah, for now I'm just going to create a basic platform. Then I'll create one cube. Yeah. Why not? I'll create one cube. Scale it right. Over here now you see we have certain objects which have certain mesh rendered onto it. But for those who maybe some of you might have noticed, these objects don't have a texture or a material. They're just what they're showing right now is the default material, as highlighted in the bottom right of over here where I'm hovering my cursor. It is a default material using a default shader. So I want currently right now I'm just using a placeholder material. So I want to make it look more visible, because right now I'm both my plane and my of course both my plane and my cube are of the same color, and it's hard for me to distinguish it. So from in my assets, I'm just going to create a new folder. Okay, so I've already created a few materials, but I'm just going to create it again. I'm just going to create a folder named materials. And then in this materials, I'm going to create a material, of course. And in the material, you have a few, of course, you have all these parameters that you can change. Albedo is basically the light diffused, the amount of light that is diffused in the material. For now, I'm only gonna like explain about albedo. And metallic and all metallic, normal maps, height maps are all basically some stuff in the intermediate. Metallic is of course basically like it's just it gives you a glossy effect for your material. Apart from that, it is not really like uh, too deep to learn. Normal maps, height maps, of course, if anybody uses Photoshop, I just and I would just like I recommend you to try like exploring into creating texture maps. So you can just have an then what else? If you want to know like what normal maps and height maps is, that is a good starter point. And then we create. I'm just going to add a certain color to it. Cool, right? Okay, wait. Yeah, I'm just going to add a certain color. Of course, you can see my materials changed. Now in my cube, I'm just going to add this material. Wait. Okay, I'm just going to drag and drop. This is, of course, this is a, of course, now I've added a material to my cube, and then what? Then I'm just going to rename it. Just going to make a few changes and rename it. Material, and then I'm going to create a few more materials for this. Just a minute. Materials get a little more gray in color. Yeah, cool. So right now, let's get into a little bit of scripting, so that you can add a little bit of like mechanisms into this cube. So for this, I'm going to just create another. Okay, I just added a script. So I'm just going to add another folder, which is with the name. And I'm just going to add a. I'm just going to like showcase a few. Okay. For now, I'm just going to showcase a few functions that you can like play around in this cube. So, okay, so as you open a script in Unity, of course you can see leaving the dependencies aside, you can see like once you get into this class, you can see a certain part of functions that it gives you beforehand. This is the like this game logic of these two functions are basically the same in every game in most of the game frameworks and in almost every engine. So void the start function is basically where, as it says, the start is called before the first frame update. So as soon as you start your game, whatever parameter or whatever value that you initialize in the start function, whatever value that you add, or whatever parameter that you add to a variable in the start function, it is uh, it is the first thing to like run or get executed in the game engine. So usually a lot of initialization stuff is done in the start engine, and then of course there's the update. There's the update is basically kind of like a while true loop. It keeps on running infinitely, and this is called also once per frame. So when it is called once per frame, of course it there is a lot of performance performance going on with it. So, and there are a lot of optimizations based on it. Usually in a framework there is also another function called as the render function, where you like for a 2D framework, sorry, for a 2D framework, you usually use this render function in like Pygame, I think. Yeah, Pygame, I think it's render, or it's either render or draw. So either if it's render or draw, both of these are used to like render on the screen objects on the screen. Since we are using a game engine. Oh wait, dude, can you see the Visual Studio script that I've shown? Is anyone there? Okay, yeah, okay, that's my bad. I'm just going to share the screen. Okay, now it's visible, right? Okay. Okay, so I'm just gonna like go through it again. Of course, we have our cube functions and in the script, of course, apart from the dependencies, we also have our class, which is inherited from this word that you can hear, mono behavior. Mono behavior is basically where all the Unity API stuff is API is stored, and it is also called as a mono develop. Apart for now, I've said I'll try to generalize it as much as before. So, and also, yeah. Right now we have a start function and we have our update function. And our start function is basically like our init. In Pygame it is also known as init, like the initialization function, where you like initialize all the variables for the game, and where you like set values for the game and other stuff. And of course there's the update, which is like a while true, which is like a while true of a game implement of the game, which keeps on executing like frame by frame, so that your game runs smoothly. And usually in an API, sorry, in a framework, you also have another function called as the render or the draw, which are also like render or draw, which are basically used to like render 2D images on the screen or the window that you're creating in a framework. In our game engine, of course, we have like tools that are also which are already rendering it on the screen. So yeah, that's why Unity only has like a start function and an update function. And starting from here, I think one thing we can like, I'm just gonna like show some few like code. So for now, I'm just going to initialize a private. Of course, I'll just start with a simple script. I'm gonna just like explain about what initializing, like what are the perks of like using a private or a public in Unity is. So I'm just void start, then log. So yeah, what I did over here is, of course, I've initialized a value, and then of course, I've defined a value, I've initialized it in my start function, and then the debug.log is basically a print function where I will like where I will like showcase this value in my which showcase my value in my console. So if I just run this game, yeah, it's okay. Now that I've added it. Print value, right? Okay. Just I think I should review it here. Okay, I'm just going to. Save. Okay, as you can see, I would try. I tried, but under was I didn't save it. Okay, so for as I've tried to print my value on the screen, you can just see it on the debug.log section session. Like I've got this value of 3, but right now I have it as a private value. What are the perks if I just kept it as a public value? So I'm just going to save it. This is my camera movement to my cube. So now I've just added the script onto my cube, like onto this cube. So if you want to know how, if you either you can drag and drop your script onto the object, or else you can just keep it as add component and mention your like script name over here, which is my script name is cube function. So if I just add it, or if I just click on this, I can just add next function. So one thing is, if since I've added, like now that I've initialized it on my cube, I can now if I set it as public, I can of course I can change my value to whatever it is. But if I'm using it in the start, as soon as I run my first frame, it is again initialized to 3. What if the perk of having public is I don't have to like always initialize it in my start. I can initialize this however I want in my game. So basically, like if I have value and this is 3, and now that I've removed the value of 3, I have a value of 0, which is 0. But now if I like, now that I know I can change this value to whatever I want. Now if I, for example, if I'm instead of running it in this debug.log value in my start, since it's only initialized once in my frame, if I run it in my frame, if I run it in my update, which is run over more than once, and I save this, now you can see it is called 0. It is called frame by frame as 0. Now I change it to 3. I can change this value however I want. But if I now, but if I change it as private, I can't. I don't have access to this. Of course, we usually, like in an object-oriented programming language, we use private because for better encapsulation, but it's for better protection of this value. Sometimes we don't want to like show this value in the function script, and we want to run it implicitly in our cube function. But this also like sacrifices. But like for example, what if there was a case where I wanted to like show this in my inspector element, and I also wanted to like keep it private, like for whatever reasons I mentioned of encapsulation and a better protection of data. For that, there is a concept, like a concept in Java C++ known as a serialization, which is basically like you break down this part of data into a data stream, and you store it in a file where you can recreate it and use it in any other platform. So now I'm using this value uh, in my Visual Studio platform, which is again being used which is again being used in this Unity platform. So now I want to serialize this. Usually, if you change this int value into public, it is serializable, or it is automatically serializable. But for a private value, if you want to serialize it, you just type serialize field. Once you type serialize field and keep it as a private int value, and you just save it. You get access to the value, and you can you can change the value while keeping it private. But if it is private or only private, then of course you can change this. So yeah, after that, now I want to change some parameters in my field. So now, just for the case of one way is I want to change some parts of the field. For now, for the sake of this tutorial, like so sake of this workshop, I'm just going to like show like basic transform, how to show basic elements like position, rotation, and scale. And for the other parts, you can just check out the documentation and the API and how to change those. There is basically like a code snippet for each and every part where you can keep on changing stuff. So for that, for this, I'm going to change. I'm going to try doing some rotation of the cube. So for that, I want to rotate this for n degrees per second. For this, I'm just going to change this value to like rotation speed. And of course, I'm just going to remove my debug.log value. Now I want to change my transform. So once I go, I'll just type it. So now currently right now, this is the function that you use to actually rotate a screen. This is a little bit of Unity API, but I'll just explain the reason why you why are we actually doing this. So like transform.rotate shows an error saying that it needs some Euler's, basically it needs some angles to cover and some angles to cover so that it can actually start rotating. For that, I'm going to initialize one more data set, which is also called as a vector. What, so I'll just name it as V. So this vector3 is a data. You can just check out the definition in the definition if you want. A vector3 is basically a data set where it is a three-dimensional array which can store values of three parts, which in Unity are like the XYZ of the XYZ coordinates of our object. So if I just 3D, yeah. So this is initializing this public vector V. Then now I'm just I have rotation speed, and okay, now I'm just going to initialize this vector into my in my start function, so that at the start I just get my values. Is equal to new vector 3. For now, I'm just going to add some float. Now we can see like vector 3 has a few formats which are taken as floats. So I'm just going to add some random values of 1.0. And I've initialized my new vector, so now I can just add it and put in my rotate. So currently, right now in this rotate, what V does is we will rotate one degree with respect to the x-axis, 1 degree with respect to the y-axis, and 1 degree with respect to the z-axis. I'm just going to add some rotation speed. Like since my rotation speed, I can change it to however I want. I'm just going to add it here, and I'm just going to save it. And where's my camera? Just going to show. Now will this work? Let me see. Speed, yeah. Now, as you can see, as I change my rotation speed, the cube rotation speed also keeps changing. And do notice that our objective for now is to create a rotation of a cube with n degrees per second. But since it is rotating 1 degree from each axis, and I'm just keeping a speed like 3 degrees. And currently it is synchronized to the frame rate of my application of my game engine and of my screen. So, and it's, if I check out my screen, the update is called once per frame. So if I add a vector and a rotation speed to it, and I keep on multiplying a number and just keep on updating it, I'm just gonna I'm rotating like 1 degree with each axis respect to per frame. This is a kind of a problem, this is a kind of a problem when you're like showcasing this game and like different yeah, machines, like in different if my laptop might have like 200 fps, and another laptop might have 60 fps for that day, and if the game is functioning like that with respect to the frames, it is gonna result in like inconsistent functionings. So what we can do over here is use case, or very important, like this is a very important concept of time dot delta time. As you can see, time dot delta time is basically it takes the time difference of each frame, and this time dot delta time gives a more uniform rotation, or like in this case a more uniform rotation to this cube. So if I just save it, I keep on rotating. Now I see before I like before I would like to use a rotation speed of 3, and now if I'm using 19, it's much more slower than the before one, because I'm currently like rotating 19 degrees from each axis per second. So apart from that, I think since I'm running on a timer, I'll just showcase a little more scripts before, and maybe and also I'll like code review some stuff. Wait, where is it? I made an implementation before so that I just don't run out of time. I'm just gonna save this. Yeah. In this code, I'm just gonna show one of the scripts, which is cube camera, which is now that we know how to like initialize a value and how to like change values in the engine. I'm just gonna show like how to like take more how to take more inputs from the game and like show it into the screen. I've initialized some values which are like value, force value, speed, and player. And then I'll just explain this later. For now, I'll initialize 3 values. I've defined 3 values. I've initialized 3 values. Then I've set up a rigid body I've set up a rigid body. Then yeah. Oh, from here, what I've taken is input dot get key code dot space. This is basically what I'm taking as my input. The input API is a kind of necessary because I can't try generalizing it. Generalizing it. Basically, the workflow over here is if I press space, as soon as I press space, the input API, sorry, the input class will return me boolean, which is true, from which I can run this run this conditional statement. As you can see, debug.log. This is basically what I did was in the previous example. Instead of like running it frame by frame, I just pressed space so that I can just update the value one by one. So, and yeah, then what over here you can see I've added like if I press W, I can add a force. Okay, over here I've used a little bit of like generalized words, so I'll just explain it. Player RB is basically the variable which I gave it for the rigid body class. Rigid body is basically all the stuff that you use for implementing implementing like the, what do you call, implementing the physics of the game, physics of that object. The rigid body, of course, rigid body gives you like gravity, force, velocity. In any other framework or in like Unreal Engine, usually they don't. Many of these don't have like a physics class. There are like two alternatives that you can go for it. One is you can like search for a physics library for that specific framework on GitHub, and you can try implementing it into your project, or else you can just go from scratch and create a classes one by one. For each and every physics part, showing like using a physics formula, like we for calculating velocity, you like add certain acceleration parameters and time rate, v is equal to u plus at, and other stuff. You can setting up a mass to it, setting up acceleration to it, then setting up a force to it. You just do it by scratch using using all physics parameters one by one. Now, as you can see, if I sorry, as I press W, my rigid body I've called my rigid body object, which is instantiated, and then I've added a force to it. Vector 3 forward, and vector 3 forward is basically a short for 1.0, so 0.0 and 1.0 f. Basically, it's going towards the z-axis. Back for forward it is 1.0 f. For back it is minus 1.0 f. Left and right are of course the x-axis, so it goes around in the x-axis, and up and down are basically for the y. So if I just forward, I'll just back, down, left, right. These are like shortcuts you can use when you're like just trying to implement a basic movement for around the left y-axis and z-axis. Then yeah, once I've added a force like towards the z-axis, I'm making sure that my object is moving smoothly. For now, I like added force. I can also like change as I've mentioned before. I can use also my positions and change the way, do whatever I did before. Like instead of like changing the rotation, I can like change its position and add time dot delta time and stuff. For force, it is more like physics oriented. So it already like satisfies the criteria of like using or not using time dot delta time. So after that, now if I like press W on my press W, I can move forward, move backward. Now if I just collide with this object, you can see in my console, I get one message saying collision occurs. Now this is basically what I've implemented in the script. So I'm just going to show it for now. Like yeah. Usually in the frameworks, you don't usually in this engine it gives us a ready-made static method, which is basically on collision enter. You can like functionate the criteria for how to like showcase and extract information from collision between 2 or 3 objects. So here collision, I'll just name it to collision info. Like collision is a class which takes the which describes the collision, which takes information of each and every collision between like each object. So if I just name it collision info, here if I just named my okay, I should change everything. So over here I've just mentioned my collision info with a tag. Oh, I'll just name in my game object. Okay, in my game object, this green. I'm just gonna get this wall, and I'm just gonna name. I've named it collider over here, but I'm just gonna name it as wall for now on my top right. Or I just renamed it. So if I just game object dot name. So here I'm basically calling my calling whatever I call as calling my wall in my on collision enter function. And over here I'm just asking that if if the game object, the script that I kept, the player controller script that is referenced with my cube collides collides with this collides with this game object which I've called as wall, which is also a part of the viewport. I just have to show up a message saying debug.log collision occurs. And basically that's what we get as a print screen. Collisions are basically useful for of course useful for like implementing physics something. On trigger enter is something a little bit different. Like if I just go over here and I mention my box collider, you can see an option called as is trigger. So if I press is trigger and just run the game, you can see my like it just passes right through. Why does this happen? So basically on trigger enter is a function. Usually triggers in a game are like mechanisms where you want to show like where you want for the player to be in some cases. Like suppose if I'm going in a field of suppose I'm playing a shooter game, and if I'm while I'm playing a shooter game if I want to heal in a certain area of that of the map. So in that certain area, once I go inside that area, I get healed up. So to implement such mechanisms, we use triggers. If I just place I place in this type on this mesh or this collider in a certain part of the area, and I just like go through it. I get the information on my on trigger enter function, which then I can use for sorry, which then I can use for whatever implementation I'm trying to implement in my game. Right now it is collider, so I'll name it as wall. As you can see, the trigger event is called. And before that, wait, I'm just gonna like comment a little bit of code before going to this part. So usually in a normal game, once you like, I've now shown you like how collision does not exist in the current context. You can comment this. Yeah. So now while I run this game, usually in a game now since I triggered it, once it goes through, it's again it's an endless loop into the void. You keep on rotating whatever happens to this. So one part what happens over here is I've already mentioned about scenes, like what a scene can like. Once you go into your build settings, you can like index all these scenes in a certain list, and you can iterate through these scenes one by one, and you can create like a level mechanism in your game. So if once I have one stuff with my scene is done, I can move on to the next scene. From that, I can move on to another scene, and like that. So right now, what I'm doing over here is I've called a dependency like a named scene management. Scene management is basically the part where you like show like how you can manage your scene and stuff. So with this, I've I made a function called as restart scene, where I want to like once if my player falls, since my at the moment my play in position are all at wait, this is going for canvas. My plane are all at zero. My XYZ are all at zero. Now, if it goes little bit of negative, I just want to reset my whole game. I reset my whole level so that I can just like implement it once again. So yeah. for that, I've just implemented like I've loaded the scene, and then I've just called out the active scene that I am using in my game. So and of course, the get active scene refers to like the currently active scene which I'm using. Load scene is basically the the function that allows you to load this active scene which I'm. So if I just go if my y position, my transform, the y parameter of my transform position is a little bit negative. For now, I just added a little time, so I just added minus less than -3. I want to restart my whole scene. So for that, so basically that is how you get to restart your whole scene and everything. You can like explore more about scene management for like get index to scene, get index scene, and you can add your number. For this, it's usually in the build settings, like scenes in you see scenes in build, right? You can add open scenes and add multiple scenes to this. For now, I added my sample scene, and I can keep on adding one by one. You can see this is the index that I've been talking about, 0. And if I add one more scene, it's 1, 2, 3, and stop, and so. Then I kind of wanted to, what else? Where are you starting? Yeah. One more thing is basically instantiating an object. For this, I wanted to actually like show a little separate implementation that I did once when I've been learning. So right now you see there is nothing on the scene except for like some imaginary frame that is over here. This imaginary frame is actually like, if I go into the 2D part, you can see, and I press on some object, you can see whatever is happening over here is basically, this is where this usually in Unity, this is where you implement the UI of your game. So for that I created a I went to UI and I created a canvas. From canvas I added a text which basically helps lets me know to check how can I check the FPS of my game. So for that, before that, if I go back to 2D and just hit on my object, you can see I have basically nothing on my screen right now. But once I press play, you see I got a few terrains instantiated over here. So what is happening over here? And you can see like a ton of cubes keep generating. So what did I do over here? So basically over here, the whole function algorithm, whatever I did is, I've like instantiated a game object. So what is instantiating a game object? Instantiating a game object is basically, if I go into my script, that over here it was what is it? Scripts. The script that I used over here is generate voxels. I had it open in my game, so I'm just going to show. Instantiate game object is basically you can like spawn a game object into your game frame by just mentioning its position and its rotation. Quaternion identity is basically quaternion is basically the class to represent angles. Identity is basically showing that it is 0. So this is basically to say that there is no rotation in my object as of the moment. So what I did is I created a 2D space with respect to my x-axis and z-axis. I've run this as a loop, and then I've initialized it as my x and z. Then I've used something called as Perlin noise. Perlin noise is what is Perlin noise? Perlin noise is basically a noise algorithm. It's a noise algorithm. You can, if you want, you can just check it out. On the internet as how it works. In Unity, it is built in. Perlin noise can also be used for shaders to create like cool stuff. So I definitely like just try to check it out what it does. Perlin noise is basically, it like shows for now here I'm using it as my height for a Perlin noise. Basically it fluctuates between 0 to 1 to 2, and these parameters that I added over here are basically like to just to add a little uniformity over here. If I didn't not adding or not okay, wait, is there a chat? Yeah, Perlin noise generated terrain, yes. Perlin noise is basically like a noise algorithm. Yeah, which Perlin noise that if you want, you can just Google as height maps. I think I just told you, like, if you want to go Google height maps, you can Google height maps. Are basically, if I just right now I'm not using any mesh rendering. Maybe if I want, I can show my project later after once this workshop is done. So over here, Perlin noise acts as a noise algorithm where if I just draw a graph and I show it as a show it as a like so a draw graph with respect to Perlin noise with respect to my y, and if it's taking some parameters as x or y, it is a like a very clunky graph. It goes sometimes it goes up, sometimes it goes down. This 10 of don't care about it for now. These are basically the stuff that I added to like make the terrain a little more uniform. If I just don't add Perlin noise, it instantiates yeah, that is basically it. Yeah, basically you give it as a height map variable. And so I've used Perlin noise. I've instantiated it on an x-axis, and and for my y, basically for my y parameter, which is my height, where I want to add the height of each and every block, I've instantiated it as a terrain. So if I run it over here, over here it's a whole this whole complete terrain over here you see is created only purely with blocks, and the height that you are creating, it's kind of similar to one of a game that you might have known, but yeah, it's basically to create voxel styles voxels. These type of terrains are also known as voxel style terrains. So voxels are basically like pixels with some volume. Here you use for smoother terrains. Okay, for smoother terrains, there is a concept, as I've told you, you can use meshes. Meshes are basically I'll show, if I want, I'll show my project later. Like if I want to use a there is this concept like you can create using meshes. Like you can initialize what you can see this grid on the game instance, right? If you like you can these are like instance one coordinate from each and every part for one unit. So if I just want to like spend like some time on mesh rendering and how to mesh basically like instant vertices on the game instance, then you render the mesh on the xz with the same logic that I used over here, which is on the xz axis, and then I use Perlin noise to like add a height between each and every vertex, and then I start rendering the mesh. Uh, if I want, I'll show it in my old project. I think opening it will take time. I will show it later if you want. I think I'm running out of time. Yeah. So yeah. Then after this, you can see over here. I've tried to like show some number over here, right? This is basically the frame rate that I'm showing on my game. So for this, how I did this was, of course, I created a UI part, set up a canvas where I can display my text. My text over here is the FPS counter. I the whole UI part. If you want, you can if you want, you can try it out. These are basically just random stuff that you basically alignment stuff, position and stuff that I mentioned before in the Unity engine. Over here, where I can like initialize my text variable. Over here, I've just added some random text like text over here stuff. But for this, I've initialized an empty object to run my like to run my script, and which is known as a display FPS. I think I have it open. Yeah, for display FPS, basically, what I did this, I serialized it as frame rate, and the frame rate is basically this is the number that shows the frame rate, and I've tried to like print it into a text. So for that, FPS text.text, I've made it into I've got this as a part. If you unscaled delta time is basically the time taken between two fixed frames. There is a difference between delta time and unscaled delta time. Delta time is a like normalized to a Unity class known as a scale time, which allows you to scale, which takes the difference even when there are any fluctuations. Unscaled delta time doesn't takes the time between two fixed frames, no matter what. Scaled using scale time, it ignores that delta time ignores that fluctuation. Since we want to show our frame rate is kind of like a frequency, right? So using that logic, I've showed it as 1 by t, which is basically 1 by time dot the unscaled time. Over here, like you can see this function of invoke repeating. Invoke repeating, if I just remove this, and play. Oh, yeah. If I just instantiate it in my update function, so if I just run this function that I made to show frame rate and FPS text on my function, then I just run it out. You can see I'm getting a way too dank number of like uh, frame rate showing without any delay. Like it is showing for each frame, and I don't know what to comprehend from this number. So I just added a little delay to it, like showing like I just showed a little delay to it by adding invoke repeating. So basically, this function this function calls the function that I've been using and gives it a delay of like 1 second. This is the delay I get before I call the function, and while I'm repeating this function, I get a 1 second delay. That is basically what this function is. Then, yeah. So apart from this, so yeah, that is what I wanted to show. I think, yeah. And yeah, if anybody has like installed Unity, make sure you get the Unity hub so that when you start a new project, you get these few options of like 2D, 3D, and high definition RP and universal RP. So what are these render pipelines that you're seeing? So render pipelines, I'm gonna just explain it now. And also a little version control. Yeah, okay. So yeah, I'll just close it. So coming back to this, now that you know, now I've already mentioned about UI in games, like it shows you like HUD stuff that it displays on your screen, which the user cannot interact with. Graphical user interface is all, the rest of the UI that you use in a game while you're interacting with the UI, like the settings, the volume bars, and all this stuff. Now, now I mentioned what is the like. Just a minute. Share the screen. Yeah. So as I mentioned before, what is the render pipeline that the game was talking about? So that is a part of the computer graphics that we're going to talk about. So computer graphics are, in short, of course, all the stuff that you see on your screen are computer graphics, right? It is either pixels, shapes, and vectors rendered on a computer screen. So these are, before we go into render pipelines, we need to know a little bit about the basics of it. So rendered graphics are classified into raster and vector graphics. Raster graphics are basically all the pictures that you see, all the stuff that are rendered in pixels, and these are also called as bitmaps. Since they are made of pixels, sometimes you see a lower resolution picture and you go, I can see the pixels on these. It's almost as if you can see all the boxes of pixels on each and every of the corners of the pictures, like on the edges of the pictures. So that is those are actually those in graphics are actually called as jaggies. So like the jagged edges are usually undesirable stuff that you want. Usually if you want to show the picture in any resolution, it would be like in a smoother perspective. Like you don't want to show the scores perspectives in a game between between like 2 to 3 objects. So for that, there is this concept called as anti-aliasing, which is a post-processing effect. Post-processing effect in any framework or game engine. If you want, you can check it out. That basically just smoothen out the curves and also adds a softer like shadow effects as well. So if you want, you can just check it out. And of course, raster graphics are good for, are very much ideal for like hand-drawn digital art and stuff as a storage. All the JPEG, all the dot JPEG and the dot GIFs that you see in your all the files that you see in your computer are basically raster graphics. So apart from raster graphics, there are also vector graphics, which are instead of like made up of pixels, they are made up of mathematical algorithms and formulas. And so one big example of vector graphics are, of course, scalable vector graphics, .svg files. These are very much like ideal for showing like a definite geometric type of vectors, like few for more intricate rectangle graphics and other stuff that you see in your either you see in your front end or even for a game. So these computer graphics are also use of a graphics API, which I've already mentioned before, which are OpenGL and DirectX. OpenGL is more for cross-platform thing, cross-platform API, which is written in C++, which also you also use, of course, the shading languages. OpenGL uses a shading language, also known as the OpenGL shading language, which is GLSL in short, and DirectX uses a high-level shading language, which is also termed as HLSL. So it is of course, DirectX is a proper DirectX, and of course, yeah, I forgot to mention OpenGL. Even though it is named as OpenGL, OpenGL is not an open source library. It is because the one reason is because you see all these graphic cards and all these graphic drivers out there made by like NVIDIA and Intel. So both of like every graphic card manufacturer has a separate OpenGL API, has a separate API. That is one that is one way you can say that OpenGL is not like open source stuff. And then there is DirectX, which is also, I think, which is proprietary. You don't know the source code of DirectX as well. And yeah, most of the you only know you can access the API though. So most of the games that are made in Windows and that you run on Windows are made of DirectX. And so for this to like for these graphics to get rendered onto the screen, you have to like even for these APIs, they have a certain set of processes or functions that they have to do to render it onto the screen. So this rendering is called as this rendering process is called as a render pipeline. So more about this. So this diagram that you see over here is basically a render pipeline for OpenGL. So over here you see some vertex, some terms that are vertexes, shaders, post-processing, and rasterization. So little bit TLDR for this is basically vertexes are basically stuff that basic are data buffers that store some values like textures, materials that I've shown in the Unity engine. Then comes the geometry then there comes the shaders. Okay, what when like there are a lot of buzzwords over in the industry, which even like everywhere you go, you hear like realistic graphics and shaders. What does anybody have an idea what a shader is? Like anybody can give a guess of what a shader is? Anyone? I think got a little bit boring with it. Yeah. But yeah, okay. So shaders are basically once you render a picture like you see this process called as rasterization, right? Rasterization is basically the process of going through like what now I told about raster graphics and vector graphics. Vector graphics are it's basically converting these vector graphics into raster graphics, basically known as bitmaps. Then this bitmap is again taken into a what would you call as a a shader, and then this shader is then this shader helps you to render this whole raster bitmap into the screen. Then of course is realistic, or then as I said, there are a lot of buzzwords over here saying if it is realistic graphics or not. So are realistic graphics always the answer? uh, for that it depends actually. So if it is either realistic, if it sometimes it might be good if it is realistic, but sometimes there are a few games with really good graphics which couldn't make it into the market. So yeah, computer gra- uh, computer graphics, of course, computer graphics from a design perspective, there are some areas that define good graphics. One is consistency. Of course, there is visual aesthetic and all. Visual aesthetic is basically the look, how it looks, and there is color theory. Color theory, for more information about color theory, and I'll just share a link. Like, where is this? So over here, the whole computer graphics thing, since we mentioned it, one thing with good consistency and visual aesthetic, apart from the visual aesthetic, one thing with good consistency and good color theory is that even if like you show a low rendered or a silhouette of the game that you make, if it has good consistency and color theory, it is very much noticeable. This is also the same for character design as well. So for example, over here you can see like it's just bits and pieces of a few rectangles and spheres here and there. But yeah, maybe some of you might have noticed what game it is, and I'm just going to leave it at that because yeah, this is pretty much noticeable what game it is trying to show. Yeah. So yeah, then of course let's try brainstorming some game design. Of course before I went a little too technical, and I just try to like mention some stuff here and there. But yeah, over here, yeah, we might talk a little bit about games. So yeah, just you can get ready. So what exactly is game design? It is the whole process of designing a game idea and trying to adjust it into this framework, trying to adjust it into a game. It makes sometimes some developers say like if the game design is to make the game fun. It makes sure that if the game is fun or not. But fun is such an objective term that sometimes some might go for the fun aspect of it, and some might go for any other aspect. So it is kind of an objective thing. That's why game design has a lot of abstract part to it as well. Then of course, if you look at the game designers, apart from going for the idea and trying to look for the design document, of course he also has to look over like if the core, the mechanics of the game, the aesthetic of the game, and the whole level design of the game are completely are consistent and are completely like integratable with the game, and the end product should become like a noticeable game. It should look like a game. It should not look like some it shouldn't look like a scuffed up version of any other bad game that you might have noticed. That is basically the distinguishable factor between a good game and a bad game. So what makes a game recognized as a game? You might not. So what is the difference between a movie and a game? If somebody asks you for that, there are a few parameters, of course, for a game, right? You for that the yeah. So for that a game has certain elements. For that you have a actor, you have a player who gets spawned, who has an end goal. Basically, he has to achieve something. For that, he has a certain opposition. This can be either enemy or else challenging platforms. Then of course you can the decisions he has to take either through this can be like the movement that I mentioned before. Either he can explore, either this can be done through exploration, or else if you're not playing like a visual novel, then it is also of course picking up your choices where it matters. And a much more concrete representation of this game design would be basically if I start, and there are multiple ways to play a single game to achieve a single to achieve a similar objective. So there is, when you, a good game would be actually there a good game would be actually when the game is played, there is no like one single best optimal way to play it. You can either speed run through it, or else you can either play it in your own leisure time, and there are a lot of parameters for this as well. Yeah, kind of. So what patterns do you like that make a game engaging? There are I'm just gonna like leave it yeah, how many are there? Yeah. I'm just gonna leave it for like 2 to 3 minutes. If I don't get a response, then I'm gonna just continue. So yeah, is like, what are the methods, or like what are the features that you like in a game that you would like to see in any other game? What is that you like admire in a game? That is this is simple. Like, yeah, good background music, right? Yeah, one is good background music, of course. So yeah, I'm just gonna continue. It's 1:45. Yeah, a theme of the game, exactly. Yeah. So yeah, for there are a lot of recognizable patterns in this paradigms or patterns that you can check in a game. So for that, I'm just going to show you some parts where you can like, so you can go into the game and like check out, okay, these are some elements that, yeah, I can try out and like judge a game through. You can't just go blatantly judge into a game and this game is bad, and you can, and rather, and just not proceed to explain what is the bad element of a game. So for that, of course, starting off with the importance of a genre. There is a very famous saying this is a very famous quote of, amongst the games designers, saying that you don't have to like reinvent the wheel to make a new game. Basically, uh, like going to the exception of like the oversaturation of FPS games in the market, like shooter games in the market, a good genre, of course, like determines, gives you like a good setting of what game it can be, and like any user can also find it find it according to their preference or interest. Trying to create a completely new game might be revolutionary, but once it goes into the market, it is a completely different thing. That was one of the problems faced by game designers. That's why. So if you can't really blame them if they like go for another shooter game as well. Then comes the element of experience, which is the aesthetic, like the look and feel of the game. As mentioned before, like some before, like with the background and with the background music and stuff, like a good background music, good sound effects, good graphics, and yeah, good graphics and a good gameplay. These all determine how much you like the game. The element of difficulty is, of course, like you play a game like Dark Souls, and it's a or you play a game with like easy, medium, and hard difficulties. Then you feel like, okay, I'm just looking for a casual I'm just looking for a casual experience. I'll go for easy. Now that you played in easy, then again you caught up a sense of you caught up an element of progression, where you want to go like, okay, I played this at easy, how does it feel like playing it in hard, medium, and hard? Can I like develop like better can I get better while using medium and experience? And of course, uh, that also gives you like, once you go for like medium and like hard difficulties, these also give you like a chance of element of risk and reward. Basically, one going for medium and hard, you of course, there is a little time you can spend before you have to spend before like going through like each and every one. You have the risk of like losing even more, but the reward at the end, which would probably give you a dopamine rush. That's one part of it. The element of chaos and chance is basically, okay, before this, I would just like to like mention, a good game design doesn't like become like it's not only like limited to video games. It is also any as I mentioned before, anything with a starting goal, end goal, and with objectives and rules can become a game of tennis, a game of cricket, or a game of chess. Board games are also a good example of this. So in an element of risk and reward, a very good example for any game of risk and reward is snakes and ladders, or even any of the like there are elements that are in video games as well, like randomized chess, randomized loot drops and stuff. Then you have the element of balance. We'll be talking about it later. And then you have the element of immersion. Like immersion again comes is codependent with experience. If you have a good narrative piece in your game, that also helps you in like giving a good immersion for your game. You get to like get invested in your game, and you like to mention, oh, okay, this is what I can do with the game. This is how I can adjust. This is what I have to do. This is what I need to do. This also gives you like this also like that every decision you make gets you more invested and engaged into the game. That is what the element of immersion would mean. And the degree of freedom could be a sandbox. Degree of freedom and creativity are actually codependent. So if a good game with freedom and creativity is like Minecraft, a good sandbox games, Minecraft or Roblox, which allow you to be free, which allow you to like do whatever you want in the game, develop whatever you want in the game, build whatever you want in the game. And there are of course some games limit your free kind of limit your freedom, and that sometimes those are like condemned upon, but sometimes limited freedom also can work for a game. For example, in like shooter games where you sometimes there might not be an element of exploration, so you just want to like go through, you just want to like go through like a game of Halo and just want to finish off all the objectives that are given. So in that case, you are navigated. That is the part of limited freedom that I'm talking about. Of course, good freedom games are of course open exploration. You it's just a lot of side quests and side, lot of end goals, some goals and sub goals scattered around the map, which allows you to like get more and more engaged into the game, and like add some good gameplay features as well. And in the end, this you can see this model of monetization. What exactly is a model of monetization? A good model can like a model of monetization is like model of monetization is basically like in-game purchases. This is not like a like the money that you spend to like buy a game. That this is the money you spend in-game to buy parts of a game. Why is this mentioned in game design? So in game design, the model of the model of monetization actually also has some sort of like can also give you some sort of a reward, the element of reward and element of progression. In the recent years, a very great example of game design with a good model of monetization is the battle pass. A battle pass allows you to give an element of progression. It gives you an element of reward, and also it also gives you additional goals that you can add in your that you can try to like progress in your game. It makes you more invested into a game, especially for a game with more limited with more mechanics and limited narratives. This is a perfect replacement. This model was actually started by, of course, Epic Games, and now it is being implemented in almost every live service game that you see today, which involves patches and stuff. So of course, for the game design, I've like catered a few case studies that which show like the problems that a game designer that might face in a company. So for that, few cases that I've seen are free for all politics and quantified creativity. I'm going to explain this before. And game balance is more of a technical look into how game designers try to balance out stuff using probability and other advanced concepts in that field. So incompatible user promises. One comes free for all. Now comes free for all product. You're in the you're playing a fighter game. Now where there are four people and four people are controlled by four players each. Now there are two cases. You can either go in this 90 retro game perspective and just beat up mobs together. For this, there are like two cases. Either you showcase your skill by mashing up those great buttons over there and use the best move set, best combo possible, and then try to like go for a, or else you can also go for a you can like cooperate with your teammates and try to like finish the game and win the game. So these two promises that a user a game developer sees these two like uh, the skill mastery and like the cooperation. This cooperation and the cooperation and so like the cooperation and trying to trying to manipulate communication between each and everyone so that you can like beat up all these mobs over here is a kind of like a is an incompatible user promise. So why is it an incompatible user promise? Playing to win with cooperation, playing to win involves politics, while playing to master gameplay skills doesn't want any involvement with politics. Rather, it's just they just want to mash up their, they want to gather the best combos possible, and they want to try to they want to try to win the game. They want to win the game by, they don't look to win the game, they want to master their skills, and they want to win the game with those skills. So these two cases are naturally incompatible with each other. So these naturally naturally incompatible user promises are almost impossible to solve by any game designer. So many games try to like get around it and try to like add tweaks to it. Now we looked at a beat 'em up, but what if it was a free for all where all four people had to fight for themselves? Over there, again, if so one very good case is of course the no, I'm sure everyone, there are a lot of people who play Valorant. For those who don't know, I'm just gonna like explain. So basically, this game, there are people who want to like master their gameplay skills. Of course, they want to like they get good with their gunplay, get good with their abilities. But sometimes when they want to play to win, that means also using all the available features, available gun sets, and basically try to do whatever they can do to win. So one problem that this game had with like showing like with these two naturally incompatible parts was there was this shotgun called as the judge. So people whenever these used use whenever they used as yeah whenever people used this part of a gun, the people this gun people, there were many people who say that the people who were like trying to master their gameplay skills was like saying these guys has no skills. Why are you using a judge and stuff? But using a judge isn't a bad thing. Like they're just playing to win, and this was within the rules of the game. So like the like this is something that you cannot like foretake in the like the beta testing of of the game. So what do they try to what uh, these for that was one part of the example. People that there are, of course there are some places where you can like balance it out, and like a problem show where you can like tweak up all the numbers and stuff so that you can like adjust up and release patches for live service games and everything. Do note that this experience, this this user promises, basically the promises that the developer is trying to fulfill for a user, these might not be noticeable at the initial stages of development. So then the problem over there is it doesn't make the game bad, but it slowly creeps up the core game design while people are people are playing the game over time. And sometimes this also shows a lack of which shows a lack of enthusiasm or apathy towards the game. So what are the possible approaches that these game companies did to make sure this doesn't happen? So one way was to weaken these user promises. Weakening was of course add an element of chance or chaos. For example, now if I take a 4v4 fighting game, and yeah, if I take a 4v4 fighting game, and over here actually in this game there was this feature known as items. Basically, so there are some randomized items that they can use, which gave an advantage to one of the players for a set amount of time. At first this sounds like this is just this is RNG, this is just random, this is just a random number generation of items. How can this possibly become a solution for that? Yeah, so regarding that basically uh, it defocuses the skill obsession. So the cure, of course, it is now that it is impossible to approach, you can only do two things. You can just prevent it or just sacrifice one of those user promises. weakening the user promises somewhat sacrifices some parts from both of these sides. So this is it defocuses the skill obsession, and this also and of course you can also do other approaches like limiting a players to one of these promises. Limiting players to one of these promises include now that there is a guy who it's okay. One good example of like limiting these players to one of these promises is battle royale. Battle royale games consist of a huge number of players in a single platform. So this is also kind of a free for all where everyone is fighting for each other. So once if people like get there is a lot of information to process amongst each and every player. So there isn't like a separate there isn't like a there isn't like a fixed approach to like I just have to fixed aim towards a certain player where you want to cooperate with him or like manipulate him into like a separate into like making him completely add some politics into the game. This is not possible. Now if you're in a battle royale, you have to play with your skill. There is no sort of cooperation and everything. Of course battle royals of course had this problem of cooperating, and it's considered like a bad practice in the game, which is like griefing and stuff. So uh, that was one way that game designers did that. One way was to limit out the visibility of the stats shown in the HUD. So in the heads up display. So in that heads up display, it locks out the possibility of politics. Suppose now if I'm showing in this game in this game, I can only see like a percentage. A percentage, never mind the percentage, but I don't see where like if these four guys are fighting each other, I don't have like a perspective showing of where each player is fighting. What is the standing of each player? There is no leaderboard over here. This leaderboard is only revealed at the end of the game. So why are they doing this? So this is basically to add more of like if the player if each and every player knew what the standing was, the and this is a 4 player game, so the second, third and fourth position would kind of might group up and gang up on the one who's on the first. So limiting this limiting player visibility kind of just hides of that part where you can where people might have the same problems that might have when you're showing up these leaderboards. One way there was also the percentage they can see, but that is a instant like for that instance, right? That percentage gets reset every time once you get a part. Now this is a 4v4, but now if you see in a battle royale, there are they don't show the standings of they don't show who's they don't show which player is in which player skill ranking and everything. Yeah. So and of course then comes you can either completely debar the skill part of the game and then go for deep politics and manipulation. One good game, usually a game with a good which tries to show good war strategy, good cooperation is one example. But also one other good example is this game, which is using which is using politics, debates, and a lot of manipulation. There is no type of skill level in this game. So this kind of appeals for the casuals, but doesn't appeal for the more competitive, for more people looking for a competitive experience. Then comes quantified creativity. This image shown over here is an example of The Sims. So what is quantified creativity? Quantified creativity is now this Sims is a game where actually where you where you can do two things, where you can go through two approaches. One is you can either be creative and develop build all these props over here that you can see, or else and as well you can also progress your element, progress your character, which is the two props that are shown in the middle of the screen, which I'm hovering my cursor over. So over here you see that a player there are you have two there are two user promises that a developer might have to in this game. There are two user promises that a developer might have to satisfy. One is they have to go through the creativity. They have to make sure that one of the user promises is I want to develop a game, I want to I want to be creative, and I want to develop build more stuff. But there is also another user promise where I want to progress my character. So sometimes progressing this character will hinder up. Sometimes this game was designed in such a way that progressing this character would take up so much of your time that you wouldn't focus upon building your stuff. So building or trying to be creative or stuff. So what is it? What is this? These are of course another case of incompatible user promises, where you want to express yourself creatively and want to progress your game. But these two are naturally so incompatible to each other. That's some people who might want to some people who want to actually who express themselves creatively in that game are completely full stopping their progress, which is a kind of which makes the element of experience completely different from what the designers or developers wanted it to be. This is actually one of the problems Sims had for a lot of years. They've been trying to fix it, but of course they are so incompatible to each other, so that it's almost near impossible. But that doesn't mean that of course again this doesn't mean Sims was a bad game. It was just one of those hiccups that they had. So of course the form of expressing yourself creativity was defined as intrinsic goal following, and the one where you want to progress your game is called as extrinsic goal following. If you want to know the meaning of intrinsic and extrinsic, you can just you're free to Google it. It is basically what the mechanism, the same mechanism of what I would explained the difference between the two. So what are the possible approaches? One is if you're looking for one is unconstrained creativity is almost near impossible, but you can try to develop a constrained creative game where you want to give the illusionation of the illusion of the full freedom of building and trying to be creative. One way is trying to incentivize the player to be more creative. One good example of this is Minecraft. There are some parts of building stuff that helps with the progress of your game. In Clash of Clans, it's basically if you try to build your when you try to build your when you try okay before I go to Clash of Clans, I'll just mention the other ones. There of course there is a sacrifice when you try to incentivize the player to be more creative. There is a sacrifice of truly free creativity. So to gain one promise, you have to sacrifice one. That was the whole motto of incompatible user promises. And of course you can either completely debar the whole I want to express myself creative thing, and then you have try to reduce it and go for a more I want to progress my game and try to be with a more creative approach, which is basically create rich and deep goals around the simulation, which kind of sacrifices the self trying to express yourself pattern. So one example of this is of course Clash of Clans. Trying to be creative with your builds, trying to go off meta, trying to be different with your builds, kind of helps you with progressing into your game. That is a kind of the constraint creativity example that I'm talking about. And then comes the rich goals system. The screenshot is taken from a game called Civilization. So the Civilization, the game of Civilization is basically there is no building that you do. You just place a props in a limited space, and you have to you have to satisfy a set of fixed goals, which you have to do no matter what. Many people are invested more on the goal part of this game rather than the creative building part of this game. So and yeah, now that we've talked about a little about incompatible user, let's go into the more how can we use technical parts in the balance of a games and try to configure it. One is but before that, what is balance in games? Simply said, balancing games is basically uh, trying to figure out mechanics and trying to tweak out stuff that results in the player's outcome, where the player finishing the game would feel fair and justified. From a more analytical perspective, it is trying to figure out what the numbers that you have to change in your game source code. This like game balance requires interpreting a lot of these patterns and numbers, and of course requires a lot of statistical computation and data analysis. This is the most intensive part where actually people hire data scientists and data analysis to try get what game you're trying to make. And this game balance is of course composed into game balance and meta game balance. Before going into meta game balance, which is kind of important for to data how data science is used, game balance there is game balance is of course there are a few parameters to like vocabularies to like determine how what can we know about the balance of a game. One is the determinism of a game. A good deterministic game will have a specific a definite action and a definite result. An undeterministic game would have a certain action, but it has a probable result. There is a probability of it happening or not. One good example of a undeterministic part is rolling a fair dice. You either roll a dice. If you roll a dice, it can either be a 1, it can either be a 6. It is a randomized number from 1 to 6. That is what makes it undeterministic. Then comes the solvability part of a game. Solvability part, as I mentioned in the game state before, like in the state machine of game design, where there are multiple ways to play the game. As long as you can reach the end goal of the game, it is a solvable game. Good example of a solvable game is of course a solvable game is chess, of course. Actually, chess is actually is such a well balanced game that it almost satisfies all the four parts of this four elements of the vocabulary that we're talking about. Solvability of the game in chess is basically, once you make a move, once move by move you're able to read out you're able to read the moves and make your moves based upon that. And of course you can either go for a draw or else you can either go for a checkmate, but you won't get any other result other than that. Then perfect information refers to the, as I mentioned before, if you play a game of chess, you try to read the situation as much as possible. And chess is also designed in such a way that you can also gather as much information as possible from your opponent and from yourself and try to make a move according to that. So then of course perfect information helps in perfect information is very much interdependent with the solvability, very much useful for the solving of a game. A truly deterministic game with perfect information will make sure that the game has perfect solvability. And of course, the symmetry of a game is basically when the player and the opponent are using the same parameters or same objects that are being used, are using the same objects amongst each other. An asymmetric game would be a game using a different class, different enemies. For example, a fighting game, or else a game with class agents, with class agents like Team Fortress 2, or even Valorant. Any other good example would be, I think there are a few board games. Yeah, so a good asymmetric game would be asymmetric part is basically when the objects used between a player and an opponent are completely different. So after that comes metagame balance. What is metagame balance? So metagaming is basically defined as the game around the game. So the game, this is basically the parts where it is not involved around the game, but affects the chances of winning a lot. And this mainly interacts around revolves around interactions between players and other external factors. For example, a rock paper scissors is actually a balanced game. You can check for the rock paper scissors triangle system if you want, where it shows that rock is a counter for scissors is a counter for paper, and paper is a scissors is a rock is a counter for scissors is a counter for paper, and paper is a counter for rock. This triangle system is basically used in any class agents game, in most of the asymmetric games as well. So, and then since it revolves around interactions of players, one good example I said before is rock paper scissors might be a really balanced game. But if you add bluffing into that game, or playing mind games with him, saying I'm going to throw a rock, then it completely changes the dynamic of a game. it consists of patterns and patterns of slides and poker are also good. Good part of a game. I think there was this video called as a casino game protection expert tries to find cheating parts in a casino in movies where basically they show a lot of metagame concepts in poker. So after that, metagame usually metagame isn't actually metagame is very important for a game which requires any social interaction on multiplayer games, because a good meta a good of course you might have heard of this term meta in a lot of games. Metagame a good balanced metagame will is complete is a instant hit in any in this whole industry. But going for trying to create a balanced metagame is very difficult. So then, and there are a lot of metagame imbalances as well. And while metagame balance might help your game, imbalance will completely destroy the game design of your game. So it is like a double-edged sword. So that's why game companies always look into fixing it as their first priority by taking user feedback, patches, and live service. Do take a note that these metagame parameters are so valuable to the, even though they are so valuable for a game company. These cannot be, these are also one of the parts that can't be recognized during the testing phase. So and during beta testing or alpha testing, these are usually some stuff that arises when a player tries to interact with each other. So sometimes during beta testing they might recognize a few. During while users are playing, it's a completely different thing. So that's why they look for surveys, user feedbacks, and they try to patch up everything with live service. This is also one of the reasons why live service games, or like games with constant updates, are currently a thing around in this industry. And of course we refers to like a meta with lots of tier lists, with lots of guides upon how to play this character and how to not play this character. One good this is I for of course for multiplayer this is we can easily recognize a meta. But what about single player games? Recognizing meta for single player games is one good example is speed running. Minecraft speedrunning is a very popular thing among Twitch and YouTube. But it wasn't like the game designer behind Minecraft specifically thought I would also create this for speedrunning. This was something that was these were techniques that were developed upon the community and are being spread amongst the community. There is no sort of interaction between the company and the player. It's all player and player, because as I said, the patterns are not noticed. And also in a multiplayer game, since the multiplayer games are deployed on a cloud, and there is a lot of data taken, and this data is this data can be the pick rates of suppose if for example I'm going to go for a fighting game or any game that has different classes of characters. Now when I take different classes of characters, I try to take the matchup between any two of these characters. For example, if I go for some characters might perform really good at one part of the game. Some characters might perform really well in another part of the game. And sometimes these characters are, when these characters go for the matchup against each other, the number of times they take the number of times where they can win, the number of times where they can lose, and all this other stuff. Companies try to fix around these games in the long run, that I've mentioned before with live service. This is where they actually try to use data modeling, data science, and data analysis to like predict all the possible patterns that the user might use this character progressing into the future, and try to make changes into the update based upon these the data that they get from how the user uses these characters. So yeah, for references, if anybody if you like if anybody is interested with the incompatible user promises, there is this YouTube video of from a game developers conference called as Cursed Game Design Problems. which is made by Alex Jeff, who is a dev for many fighting teams, and has also developed game design for this Riot game called as League of Legends. And yeah, this a lot of and current standards, it takes a lot of game design concepts from Riot as well. So you can check it out. And of course, if you want to look more into like how they use a game theory, and like how do they use a what do they call uh, Nash equilibrium for Nash equilibrium to like predict models, and like do metagame balancing. This is a good video as well. I'll just link the video one by one in the chat as well. And then of course, if you want to look into like terrain generation that I mentioned in the game engine before, like with all the cubes and stuff, you can just try just look into this video, which is basically where I've taken inspiration from, and I've developed multiple renders as well. And yeah, do join our game development event on Retropolis if possible. Yeah, and which is registrations are going to end by tonight. So yeah, thank you very much. Yeah. So yeah, I hope that you guys could take away something from this. I think yeah, the problem. I think yeah, I took up a lot more time than I would actually expect. I wanted to actually make the like the scripting part more like okay. I'll just stop this recording.